closest planet to the fictional black hole Gargantua. There's one scene that we're gonna focus on today. Have a little watch. So what's so special about this scene? Well, just in the span of this 5-second clip from this planet, a lot has happened on Earth. I mean, a lot. You might be wondering why. Well, just after they touched down on the planet, Dr. Cooper said something very important.
Go, go, go. 7 years per hour here. Let's make it count.
So 7 years per hour. What he means by that is that if they spend 1 hour on that planet, time will pass. We have person A floating nearby a massive object with a lot of gravity, and person B just casually floating in an empty void of space. Person A shines a green laser beam towards person B. Because light is a form of vibration, the laser beam has a color that corresponds to 600 trillion vibrations each second. Now, light is also a form of energy, and as that beam of light comes out of the gravity of the massive object, it loses a lot of energy. This loss means that there is a decrease in frequency. So by the time that beam of light reaches person B, its frequency will have decreased by some factor. That means instead of the green light at 600 trillion vibrations a second, person B gets only, let's say, 10 billion vibrations per second, which is a microwave radio beam. This phenomenon is called gravitational redshift. But not so fast. Individual wiggles don't just go anywhere and disappear. Since person A creates 600 trillion wiggles every second, while person B only gets 10 billion every second, the only way this can happen is if 1 second on one astronaut's clock is not the same as 1 second on the other astronaut. In other words, it only takes 1 second for a person to slower as compared to time here on Earth. Technically speaking, it is in a different time reference than we are. So by calculating the difference through Einstein's equations, we could correct the time at the ISS. Because we use a lot of references to the movie Interstellar here, we might as well just take one case study of how filmmakers do this time dilation feel in the movie. In the opening scene when Cooper and his team stepped on Miller's planet, an intense music with clock-ticking elements starts. The tempo changes over the course of the song. It's 48 BPM for the first minute, 50 BPM for the second minute,
the waves,
and it ends up at exactly 60 BPM to coincide with the ticking sound of a watch. And walked on the surface of it. At one point, we are told that the gravity on this planet is 130% of the Earth's gravity. We see the actors panting, a little bit under duress because of the extra gravity. But is this enough for this kind of time dilation? Well, actually not even close. If you've visited the surface of our sun, which is not a supermassive body, but still much more massive than Earth, you would gain about 66 seconds per year. To get to an extreme dilation, where 1 hour corresponds to 7 years, you would need such a strong gravitational field, essentially the event horizon of a black hole. There is simply no planet that can have this kind of gravity, and if you try to land on the surface, it would be so strong that it would crush you. The weight of the astronauts would be several million tons, and that's even without doing the math. But anyhow, if they wanted to get all the science right, we wouldn't be able to enjoy the movie. After all, it's science fiction, and to make a great film, a superb filmmaker often pushes things to the extreme. But in our case today, it's sufficient enough to turn the concept of time dilation into a beautiful film.
we'll find a way, Professor, we always have.
Thank you so much